Hello children, this is Sonia. I hope all of you are keeping fine. Today I'll explain how to find the square root of a number by the method of repeated subtraction. But before I explain the method of repeated subtraction, let us consider the following pattern. Now we all know that odd numbers starting from 1 are 1, 3, 5, 7 and so on. So first odd number is 1. 1 can be written as 1 square. It is a perfect square by itself. Now the sum of first two consecutive odd numbers, that is 1 plus 3. First two consecutive odd numbers is 1 plus 3 is 4, which is equal to 2 square. The sum of first three consecutive odd numbers starting from 1 plus 3 plus 5 is equal to 9, which is 3 square. Similarly, sum of first four consecutive odd numbers is starting from 1 plus 3 plus 5 plus 7, which is equal to 16, that is 4 square. So that is sum of first 5 consecutive odd numbers starting from 1 will be 5 square. Sum of first 6 consecutive odd numbers starting from 1 will be 6 square and so on. So in general I can say sum of first n odd numbers is equal to n square. So now I know that adding consecutive odd numbers starting from 1 gives me perfect squares. I'll explain this with a small diagram. If I have a square, say of unit 1 length, this represents 1 square. To this, if I have to show this in visualize this 1 plus 3, that means to this 1 I'll add another 3 squares. 1, 2 and 3. So this becomes of the form 1 plus 3, that is 4, 2 by 2 square. Now to this, if I have to visualize the third 1 plus 3, sum of first 3 consecutive odd numbers, 1 plus 3 plus 5, 1 is already there, 3 I have added, now I am adding 5. So this can be shown as drawing another 5 squares. So this gives me a 3 by 3 square, which is 9 squares. Now to show 1 plus 3 plus 5 plus 7, 1 is there, plus 3 plus 5, now plus 7. So another 7 squares, 1, 2, 3, 4, 5, 6, 7. This gives me a 4 by 4 square or 16, 4 square. So this I can visualize this pattern from this diagram. Therefore, I can say that if a number is a square number, it has to be a sum of consecutive odd numbers starting from 1. In other words, if a number is not a square number, it cannot be expressed as a sum of consecutive odd numbers starting from 1. For example, if we see the numbers 2, 3, 5 and 6, if we try this pattern, it will not work on these numbers as they are not perfect squares. So we can say that if we subtract from a perfect square, if I have a perfect square number and if I subtract successive odd numbers from that number starting from 1, I will get the square root of that square number. So to explain this, I will explain it with a couple of examples, and this method only is known as the repeated subtraction method. In the pattern we discussed just now, we saw how on adding successive odd numbers starting from 1 gave us perfect squares. Now the method of repeated subtraction is just opposite to that pattern. In this method, if we are given a perfect square number and we subtract successive odd numbers starting from 1 from that square number, we get the square root of that number. To explain this, I'll take an example. I'll take the number 36. So starting from 36, we subtract successive odd numbers till we get 0. 36 minus 1, which is the first odd number, this gives me 35. From 35 I bring 35 here, 35 minus next odd number is 3, this gives me 32. I bring 32 here, next odd number is 5, 32 minus 5 gives me 27. Bring 27 here, 27 minus next odd number is 7, which gives me 20. Bring 20 here, 20 minus next odd number is 9, which gives me 11. 11 minus 11, which is the next odd number. Now I get 0. So number of steps in which this subtraction is completed and reached to 0 is the answer or the square root of my square number. So I count the number of steps: 1, 2, 3, 4, 5 and 6. Since I completed the subtraction in 6 steps, I can say that the square root of 36 is 6. I'll take another example. I'll take the number 25. So starting from 25, I'll start subtracting odd numbers. First odd number is 1. This gives me 24. Then I bring 24 here, minus 3, the next odd number. 24 minus 3 gives me 21. Bring 21 here, 21 minus 5 gives me 16. Bring 16 here, 16 minus next odd number is 7, which is 9. Bring 9 here, 9 minus after 7 the next odd number is 9, which gives me 0. So I can see that I have reached 0 in how many steps? 1, 2, 3, 4 and 5 steps. So I can say that the square root of 25 is 5. I hope this method is clear to all of you. This is a very good method and also an interesting method. But this method is not useful for large numbers. It becomes time consuming to keep subtracting for large numbers. So for large numbers we have the method of prime factorization and long division method, which I'll explain in the coming videos. Till then, take care. Bye.